Hi guys, and welcome to another video. In today's video lesson, we're going to look at Euclidean geometry, application of the proportionality theorem in triangles. If you look at my previous video, I showed you how to prove the proportionality theorem. Now, in this particular question, which appeared in the June 2018 paper 2, it reads as follows. It says that in triangle RST, F is a point on RS and H is a point on RT such that FH is parallel to ST. RF is equal to 2x minus 10, Fs is equal to 9, RH is equal to 4, and HT is equal to x minus 2. Now, it says determine, giving reasons, the value of x. So let's look at that. Now, if you look at this particular theorem, it says that if a line is drawn parallel to the third side of the triangle, divides the other two sides proportionally. So we are given that FH is parallel to ST, as you can see. Therefore, RH over HT must equal to RF over Fs. And our reason will be because FH is parallel to ST, or we can say that line drawn parallel to third side of triangle. Therefore, we'll have an equation in terms of x which we can now solve for x. Let's write that down. So 9.2.1. Let's write that. RH all over HT equals to RF all over Fs. And our reason will be FH parallel to ST. Also include prop theorem, or we can say line parallel to third side of triangle. Okay, so you can choose either or reason. So now let's substitute. What is RH? So RH 4 and HT is x minus 2. So 4 over x minus 2 equals to RF. RF is 2x minus 10. All over 9. So we have an equation in terms of x, which will now enable us to solve for x by cross multiplying. So therefore, 2x minus 10 times x minus 2 equals to 4 times 9 equal to 36. So you can see that we're going to get a quadratic equation here. 2x times x is 2x squared. 2x times minus 2 minus 4x minus 10 times x minus 10x minus 10 times minus 2 is positive 20, and that's equal to 36. Now let's write this in the standard form of a quadratic equation. So now if we divide everything by 2, 0. Now let's factorize this. X squared, so x times x is x squared. Factors of 8 when multiplied together to give us minus 8, and added together to give us minus 7. So we have negative 8 and positive 1. So therefore, solving for x now, x is equal to minus 1, or x equals to positive 8. Now it's very important for you to remember that you are finding lengths or distances. Therefore, negative answers must be rejected. The answer is positive 8. So x will be positive 8. And that's our solution for the first question. Now let's look at 9.2.2. Determine the ratio of the area of triangle RFH over the area of triangle RST. Let's go look at that carefully. So if we now look at these two triangles that we have, RFH, let's go look at that more closely. RFH and the second triangle there is RST. So RST. What do you notice? You'll notice that you have a common angle, which is R, and that's what we're looking for in a non-right angle triangle. Because remember that the area of a non-right angle triangle, will equals to half times A times B times sine of C. So therefore, we are looking for two sides and an included angle. So we'll have an included angle in both of these triangles, which is common. So therefore, we can now cancel them off. So let's go write that down. So therefore, 9.2.2 will be as follows. So I will write down area of triangle RFH all over the area of triangle RST will equals to, so we're going to use our area formula for a non-right angle triangle. So we're looking for two sides and an included angle. Therefore, it's going to be half times RF, which is the side here, times the other side is RH, which is the side, times sine of R, which is our included angle. And area of triangle RST will be half times, so remember RST is the big triangle now, so we're looking at this whole side here. So that will be RS times the side here, which will be RT, times sine of the included angle, which is sine of R. So if you look very carefully now, you can now cancel half with half, sine R with sine R. So all that's left for us to do now is substitute our values for RF, RH, RS and RT. Now don't forget that X is equal to 8, so we have to now substitute. Let's go look at RF. So RF is 2x minus 8, so therefore that will be 2 times 8, which is going to equal to 16 minus 10, which is equal to 6. So therefore that will be 6 times RH. RH is given to us as 4. RS. So we've already worked that out to be 6 plus 9, and that's going to equal to 15. So the whole side, the length of that side is 15 times RT. So this is 4 and this will be 8 minus 2, so that's going to be 6. So therefore 4 plus 6 will give us 10. So what are we left with? 6 times 4 over 15 times 10. So we can just simply put that in our calculator. 15 times 10 equals to 4 over 25. And that is the ratio of the areas of both triangles. That is, if you haven't subscribed already to JL Maths, please do subscribe and share this content with your friends in the same grade or from other schools. Also, you can check all the videos out on jlmaths.com, like my Facebook page, Justin Lazarus Mathematics, and I'll catch you in the next video.